In today's lecture, we will learn about the Mohr circle in 3D plane part 2. Since in the last lecture we have seen how to draw a Mohr circle in 3D plane for the stresses sigma 2 and sigma 3. Let's start with a quick revision, then after we will continue this topic for two other planes. In the last class, we have started our derivation or point of discussion from principal stresses sigma 1, sigma 2 and sigma 3, and in the very end we have derived expression for nx square, ny square and nz square in the terms of equation 5, 6 and 7, and we have analyzed equation 5 by considering the case that sigma 1 is the largest of the three principal stresses and sigma 3 is the smallest. And while analyzing equation 5, what we saw, the final expression while analyzing expression 5 was like this. In the last class also I have told you that this equation is very much similar to a equation of circle. That's why we have compared this equation with equation of circle so that we can find out the center of the circle. And in doing so, we analyze that sigma 2 plus sigma 3 is the x coordinate of the circle, whereas y coordinate from this term has came equal to 0, and radius of the circle is sigma 2 and sigma 2 minus sigma 3 by 2. So with these data we have derived, with these data we have drawn a circle. As you can see that x and y coordinates are like this and radius is sigma 2 minus sigma 3 by 2. So a circle was drawn by keeping in mind that this axis is for sigma, as this was similar to x-axis, and this axis, the y-axis, is for tau for shear stress from this term, and as the center is at x coordinate is sigma 2 minus sigma 3 by 2 and radius is equal to sigma 2 minus sigma 3 by 2. However, while doing so in the last lecture there was a slight mistake. By mistake I have written here sigma 3 and here as sigma 2. So you have to correct it as this figure. Now we shall move forward to analyze the equation 6 and equation 7. We will begin our discussion or continue our discussion to analyze equation 6. So today we shall be analyzing equation 6. For that, let me write what was the expression derived in expression 6. As you can see that expression 6 was like this. It was ny square is equal to sigma minus sigma 3 multiplied by sigma minus sigma 1 plus tau square divided by sigma 2 minus sigma 3 into sigma 2 minus sigma 1. As I have also told in the last class that the numerator part does not contain any term related to sigma 2. So it is sigma 3 and sigma 1, whereas in denominator part, sigma 2 minus sigma 3 is there and sigma 2 minus sigma 1 is there. Sigma 2 is analogous to this ny square. Now since sigma 1 is larger, so that's why sigma 1 is the largest of all and sigma 3 is the smallest of all. So sigma 2 minus sigma 3 is negative, and again sigma 2 minus sigma 3 is positive. So sigma 2 being the larger is positive and sigma 2 minus sigma 1 is negative. So the denominator comes as a negative, and in order to keep ny square as positive, we have to keep in mind that numerator should be always negative so that the total expression becomes positive. So we shall apply the condition. So this condition has been applied. Numerator should be negative in order to bring ny square to be positive. So let me write the expression from the numerator part. Numerator was like this. So from here, it has been copied and written here. Tau square and sigma minus sigma 3 into sigma minus sigma 1 less than equal to 0. So by expanding these two terms, what we can get, sigma multiplied by sigma, it is sigma square, and when sigma multiplied by sigma 1, taking as a common, it is written here, and when sigma 3 is multiplied by sigma, so it is sigma as a common term, they have been written like this. And finally, this sigma 3 multiplied by sigma 1 is sigma 3 sigma 1 less than equal to 0. So as in the previous class, we have converted this in a very simplified form of a minus b square or some sort of a plus b square. We will also do it once again. So as you can see that it is tau square plus sigma minus sigma 3 by 1, sigma 3 by sigma 3 plus sigma 1 by 2 whole square minus sigma 3 plus sigma 1 by 2 whole square plus sigma 3 plus sigma 3 into sigma 1 less than equal to 0. A very simple calculation. I have also explained these calculation or this simplification in the previous lecture. Further on simplification, what we can do, further on simplification, it has been simplified like this. So this term has been adjusted like this so that it is sigma minus sigma 3 by sigma 3, sigma minus sigma 3 plus 1 by 2 whole square minus sigma 3 minus sigma 1 by 2 whole square. In the further step, it can be written as, again we need to compare this equation with the equation of circle so that the x is compared with this. So x is equal to sigma 3 plus sigma 1 by 2, and this y coordinate is 0, and radius is equal to this. This is the radius is brought from here. So when we have both the coordinates of center as well as the length of radius, we can draw the circle. So with the help of these data, let's draw the circle, and the circle is like this. As you can see that sigma 1 is the largest of all and sigma 3 is the smallest of all. And the radius is sigma 3 minus sigma 1, and this center is at this point. So between sigma 3 and sigma 1 means we have drawn this circle. This circle has been drawn, and the center is at this point. The center is equal to sigma 3 plus sigma 1 by 2, and the radius, this radius is equal to sigma 3 minus sigma 1 by 2. Since this is sigma 1 and this one is sigma 3, and the radius is equal to sigma 3 minus sigma 1. This sigma 3 minus sigma 1 minus sigma 3, and this has been subtracted so that this is the radius. So, and this circle, this blue circle was this circle is for previous case for equation 5, and this circle is for case 6 for equation 5. Now we are left with case number 7 or equation number 7. Let's see how we can deal with that. Now we will start to analyze equation 7. The equation 7 was like this. Again, it is containing nz term, and nz means the third direction cosine. Obviously, in numerator part there is no any term containing sigma 3, whereas in denominator it is sigma 3 minus 1 and sigma 3 minus sigma 2. So since sigma 1 is largest of all, so first of all we need to analyze the denominator part. Sigma 3 minus sigma 1 would be positive or negative. Sigma 3 is smaller, so this one is negative. Sigma 3 minus sigma 2, again sigma 3 is smallest of all, that's why this one is again negative. So negative multiplied by negative, denominator is positive. So in order to bring this nz square as positive, numerator should also be positive. This total numerator should be positive. very easy to analyze. So applying this condition, the numerator has been copied from here. This numerator has been copied from here. Tau square sigma minus sigma, tau square plus sigma minus sigma 1 into sigma minus sigma 2 greater than equal to 0 since it was positive. So in the next step, we have to simplify it in order to get the coordinates of the center of circle and radius of the circle. So this expression is copied from the last slide, and let's do some further simplification. It has been simplified as tau square plus sigma minus sigma 1 plus sigma 2 by 2 square minus sigma 1 minus sigma 2 by 2 square greater than equal to 0, and upon simplification this is a simplified form. Again we shall compare it with the standard equation of circle by considering only the equality symbol. We will consider the inequality symbol later on. First of all, we shall complete the circle for all the three equations so that we can complete the Mohr circle. Then after I will conclude or discuss about the results. So first of all, we shall compare this with the standard equation of circle by considering the equality sign only. So in comparison with x minus a square, x is, as you know, it is very simple. X is equal to sigma, a is equal to sigma 1 minus sigma 1 plus sigma 2 by 2. So it is written here. Y is equal to tau square, b there is nothing, so b is equal to 0. And this is radius, so this radius can be compared with this. So this is the radius. So these are some important information to draw a circle. So with these information, we will draw the circle. Let's try to draw the circle. So first of all, a vertical line or the y-axis has been drawn to represent tau. Tau means shear stress. Then after a horizontal line has been drawn to represent the normal stress sigma. Then after sigma 1, sigma 2 and sigma 3 has been indicated. Sigma 1 is the largest one, sigma 2 is intermediate of sigma 1 and sigma 3, keeping in mind that sigma 3 is the smallest one. Now this x coordinate of the circle has been drawn, whereas the y coordinate is equal to 0. That's why the center lies on this x-axis or the sigma axis. So this distance is equal to from here to here. This is sigma 1 plus sigma 2 by 2. The radius is sigma 1 minus sigma 2 by 2. So with these we have to draw a circle. A circle is like this for the stress sigma 1 and sigma 2. However, with the previous result, two more circles were there. One circle was this for, as you can very easily notify that it is for sigma 2 minus sigma 3, for sigma 2, sigma 3 for 2, 3 plane. And the larger circle was also there for sigma 1 and sigma 3 for 1, 3 plane. And the center of the smaller circle is at sigma 2 plus sigma 3 by 2, whereas the larger circle is at sigma 1 plus sigma 2 by 2. And this red circle, the coordinates and the radius has been shown. So in this way, we have drawn the Mohr circle for all the three planes, means plane 1, 2 or xy plane. XY plane is for 1, 2 plane. YZ plane is for 2, 3 plane. And ZX plane, you can very easily guess that it is for 3, 1 plane. So we have drawn the circle for all the three cases. The radius are also indicated when these derivations were being done. So this was all for today. In the next lecture, we will conclude, or I will show you that what are the different zones in this Mohr circle to represent all the stresses, and what is the maximum value of shear stress as well as principal stress. So for today, I leave it this lecture up to this so that you can analyze or conclude at your home. And for your help, I will be again delivering the remaining lecture in the next class. So this was all for today. Thank you.